wanted to show you. Now, before I jump into the code, I want to take you to a special example that I made this week for understanding cameras. Understanding cameras it's extremely simple once you see how it works. But the first time trying to wrap your head around the concept of what a camera is and what it does it's a little confusing. So, in order to make this as simple as possible, I have created a new project or a new folder within the top-down shooter app folder. It's called 5 Camera Principles. And I will switch to that now. And then I will show you what it does, and then I will explain it. It is basically one file, main Lua, 66 lines of code, which I'll zoom in on so we can read it in a minute. But when we run it, you should run it, and what you're going to see is you're going to see some random background. So you see a bunch of circles here that are drawn in the background. They're supposed to represent, in a sense, the ground, the content that we don't want to move. And then our player is the thing they're supposed to be doing our moving. So this little smiley guy is our player. And the mappings for this are left, right, up, down keys on your keyboard. And if you press any of those, make sure I'm selected here so I can move up, down, left, right. And as you can see, the player is moving, but nothing else is moving, which is not what we want. But I split this into 2 steps so you can see how it works. So here I am moving my player around, and then when I want the camera to update, you press the C button on the keyboard, and then it effectively does a camera update. Now before we look at the code, how cameras work in general is they are a frame-to-frame calculation, and what they do is the camera is initialized, it looks at, inspects if you will, the object that it's supposed to be tracking, the tracking object. So the tracking object for our games is the player. And then what it does is on the inspection it sets up some variables and says, okay, this is where the tracking object was the last time I looked at it. And then it does nothing. And then on the next frame it says, okay, has the tracking object moved? What do? I do something special if it has moved. Now, the camera we're using is a fixed camera. A fixed camera will, and there's different names for this, forgive me if you use a different name, but the essence of a fixed camera is keep the player looking like it's in the same position it always was from frame to frame and have the entire world move smoothly around it. So what that means is our player is in the center of the screen when it starts. It will always render in the center of the screen, and the world will seem to be moving around it as it moves around the screen. Now, from frame to frame, what the camera does, as I said, is it says, did the player move? Okay, it did move. I need to make it, or I'm sorry, the tracking object, I need to make some kind of calculation to make all these things realign. And how that works is, you guys sip the water here?
The cliffhanger.
Okay, yeah, cliffhanger. Okay, so let's just look at the code. So here's the code for our camera example. You can ignore the first part of this up until common. And so on line 9, I'm loading the common from our game, which has some variables like center X, center Y for the screen center. Just ease of use. I didn't really need to do this, but I did it because I wanted it to be similar to the game. Okay, here's the trick of a camera. When you make a camera, what you need is you need a group that is the frustum, the camera lens, in a sense. Not the lens, but like the part of the world that it is tracking. And then you need one or more groups that contain your world content. So you're going to have, for any camera, you're going to have a minimum of 2 groups. And my personal naming convention is I call the one that is being updated by the camera, I call it the world. And then anything that I put in there, I call content. I may have more layers. I may have content sublayers, etc., etc. But what I do is I create this group called content, in the simplest case, and insert it into the world. So now I have the world, and I have everything in the world. And everything in the world will go into content or one of its children. I will not put them into the world group. All right. So knowing that, In this example, what I did was I created 200 randomly placed circles, and I placed them between -200 and +200, the center of the screen, basically, an offset up and down, left and right of the center. In other words, let me just reload it. This is I'm freaking out here. All right, let's try that again. Sorry, this is what happens when you use a new editor. So when I load it, basically what you get is a semi-square looking shape where it's laid out 200 circles. And every time I reload this, I get a different random layout. Slowly. A little bit slower with a debugger. And there it is again. So this content all goes into the content group. Then on top of that, I create my player object, which is the object that I will be tracking. My camera code will be tracking. I also put it into the content layer. And then I place it in the center of the screen because that's where I want to track my object. So I put it in the center. And then I initialize my camera. Now there's no camera module in this example. This is raw code showing you the very fundamental parts of the camera. In a minute, I will switch over and show you the camera module and show you how it does the same things but in a much nicer way. But right now I'm doing it sort of longhand. So remember how I said that the camera needs to initialize? So I initialize my camera in a sense by saying the last X and the last Y position of the player were this, and I track those on the world object. I could put them anywhere, but for convenience, I know that the world is my camera lens in a sense. So my camera lens is tracking the last X and Y position of the player. That's the initialization. I forgot, you can't edit, you cannot type while you are running. This is one thing that keeps throwing me off. So there's our initialization. And for convenience, I set up a key listener. So you recall that I said left, right, up, down keys would move the player. So I just created a key listener that when I press those buttons and release them, it will move the player to the left, to the right, down and up, or up and down, simply by adding 50 to its X or Y coordinates, or subtracting 50. So again, if I press up, I subtract 50 from the Y. Press down, I add 50 to the Y, and so on and so forth. So I have a very simple movement model. So that's all that does. The only other piece of this code is instead of doing from frame to frame an update, I wanted to break it up so you could visually see what was happening. You press C, and that's as if the enter frame code ran and it did the update. It basically moved the world. So this is basically the initialization on line 29 and 30, and this. What will be happening in a normal situation is every frame this piece of code will be running over and over, just once per frame. So what it does is it says calculate the delta X and the delta Y by subtracting the last X, subtracting the current X from the last X. Subtract the current Y from the last Y. Now, if I was smart, I could say if dx equals 0 and dy equals 0, do nothing. But I'm just